Okay, for example 5, we have another graph. This time we're going to encounter holes. And so if we recall, how to find the holes is to factor the top, so it factors to x plus 3, x minus 3. Factor the bottom, x minus 3, x plus 1. And since we have a common factor of x minus 3 for both of them, we set x minus 3 equals 0, x equals 3, and that's going to be a hole in the graph. Okay, and then to find the y is going to be equal to whatever was left, x plus 3 over x plus 1. I'm going to put 3 into it, 3 plus 3 over 3 plus 1, which is 6 over 4, or 1.5. So that's the ordered pair 3 comma 1.5. There's a hole. Now to go on to the vertical asymptote, set the bottom equal to 0. Well, we don't do the x minus 3 because it canceled out. We just do the x plus 1. So x equals negative 1 is our vertical asymptote. And for our horizontal asymptote, I have the degree on top equal to the degree on bottom. So I'm going to divide the leading coefficients, which is 1x squared over 1x squared, or y equals 1. I'm going to go ahead and graph what I already know. I know the holes at 3 comma 1.5. So a hole right there. A vertical asymptote at x equals negative 1. And a horizontal asymptote at y equals 1. So that's the pieces of the graph that I already know. I'm going to go ahead and make a t-chart though to find some more points. Well, since our vertical asymptote is at negative 1, maybe pick negative 2 and negative 3, 2 points to the left of it. And since that's the only one we have, choose 0 and 1 for some more points. And you plug and chug essentially. So if I put in 1, I'm going to get 2. And notice that I can put in 1 into this formula right here, and I should get the same answers as if I put it into this one over here. That's because the x minus 3 is canceled. It makes it a little simpler. 1 plus 3 was 4, 1 plus 1 is 2, 4 divided by 2 gave me the 2. When I put in 0, 0 plus 3 is 3, 0 plus 1 is 1, 3 divided by 1 is 3. When I put in negative 2, I'll get 1 over negative 1, which is negative 1. And when I put in negative 3, it'll give me 0 over 2, or negative 2, which is 0. So I have negative 3 comma 0, and negative 2, negative 1. So that curve looks like this. And then 0, 3, and then 1, 2. And this curve looks like this. And notice that as I come through, I leave a hole right there at x equals 2. That's what the hole looks like graphically. Let's go ahead and try number 29. Okay. Number 29 says fx equals x squared plus 3x over x squared plus x minus 6. Okay, try to work out the problem, press pause, and come back to see if you're able to do it right. Okay, so to find the hole, factor the top with x times x plus 3, common factor. On the bottom, x plus 3 times x minus 2. Set that x plus 3 equals 0. X is negative 3 is the hole. So y is going to be x over x minus 2, which is negative 3 over negative 3 minus 2, which looks like it's 3/5 is the hole. For the vertical asymptote, set what's left, x minus 2 on the bottom, equals 0. So x is 2. For the horizontal asymptote, I have x squared is the same as x squared on the bottom. So I take the coefficients of x squared and divide them, and I get y equals 1. Set up my graph. X equals 2 is an asymptote. Y equals 1 is an asymptote. And a hole is going to be at the point negative 3 comma 3/5. So it's about right there. Now I'm just going to make my t-chart. To the right of 2 is 3 and 4. To the left of 2 is 1 and 0. Put those numbers in and solve again. Remember, I can put them in right there. So x over x minus 2 for 3 is going to give you 3. Then 4 over 4 minus 2 is going to give you 2. And then if I do 1 over 1 minus 2, it's going to be negative 1. And 0 over 0 minus 2 is 0. 0, 0, 1, negative 1. So this curve comes along here. Remember not to go through the hole, but stay outside the hole. 3, 3. And then that, I believe, says 4, 2. And so it's going to look like this. And there's a picture of the graph for number 29.